Have you ever wondered how computers understand our instructions, store our files, and display our favorite pictures? It's fascinating to think about how these machines, which seem so complex, can perform such a wide variety of tasks with such precision and speed. It all boils down to a simple system called binary code. Binary code is the most basic form of data in computing and digital communications. You see, computers are essentially electronic machines that use electricity to function. Inside a computer, there are countless tiny electronic components that work together to process information. This electricity can be either on or off, just like a light switch. When the switch is on, it represents a 1, and when it's off, it represents a 0. To represent these on and off states, computers use the numbers 1 and 0. These ones and zeros are known as bits, and they are the smallest unit of data in a computer. This system of ones and zeros is known as binary code, and it is used to encode all kinds of information, from text and images to sounds and videos. And it forms the foundation of all computer operations. Every action a computer takes, from simple calculations to complex algorithms, is based on binary code. Think of it as the language that computers speak. Just as humans use languages like English or Spanish to communicate, computers use binary code to understand and execute instructions. Imagine a light switch. It can be either on or off, just like the binary system. In binary code, 1 represents the on state and 0 represents the off state. By combining these ones and zeros in different sequences, computers can represent all sorts of information. Each digit in a binary sequence is called a bit, which is short for binary digit. A group of 8 bits is called a byte. These bits and bytes are the building blocks of digital information. Now, how do these ones and zeros transform into the letters, numbers, and symbols we see on our screens? This transformation is crucial for us to interact with computers in a meaningful way. Without it, our digital devices would be nothing more than complex calculators, unable to convey the rich tapestry of human language and communication. This is where character encoding schemes like ASCII and Unicode come into play. These encoding schemes act as bridges, converting binary data into readable text. They are the unsung heroes of the digital age, making it possible for us to send emails, write documents, and browse the web. ASCII, or the American Standard Code for Information Interchange, was an early system that assigned a unique binary code to each letter, number, and symbol commonly used in English. Introduced in the 1960s, ASCII was revolutionary for its time, enabling computers to handle text in a standardized way. However, it was limited to 128 characters, which was sufficient for English but inadequate for other languages. Unicode is a more modern and comprehensive system that can represent characters from virtually every writing system in the world. Launched in the early 1990s, Unicode expanded the possibilities of digital text representation. It includes over 143,000 characters, covering not just modern languages but also ancient scripts, symbols, and even emojis. This makes Unicode an essential tool for global communication in our interconnected world. Both ASCII and Unicode serve as translators between the binary language of computers and the languages we use. While ASCII laid the groundwork, Unicode has built upon it to create a truly universal system. Together, they ensure that our digital communications are accurate, efficient, and inclusive, bridging the gap between human language and machine code. Section 4 example, translating binary into letters. In this section, we will delve into the fascinating process of converting binary code into readable text. Binary code, the language of computers, consists of only 2 digits, 0 and 1. Despite its simplicity, it forms the foundation of all digital communication. Let's look at a simple example using ASCII. ASCII, or the American Standard Code for Information Interchange, is a character encoding standard that uses binary numbers to represent text. Each letter, number, and symbol is assigned a unique binary code. The uppercase letter A is represented by the binary code 01000001. This sequence of 8 bits, or 1 byte, is how computers understand and process the letter A. The uppercase letter B is represented by 01000010. Each letter has its own unique binary representation, allowing computers to differentiate between them. By combining these binary codes, we can form words. For example, the word cab is created by stringing together the binary codes for C, A, and B. For instance, the word cab would be represented by the binary sequence 01000011010100000010. Each of these sequences corresponds to a specific letter, and when combined they form the word cab. It's like using a secret code, but instead of symbols we use ones and zeros. This binary system is the backbone of all digital communication, enabling computers to store, process, and transmit information efficiently. Understanding this process is key to grasping how modern technology operates. Section 5. Painting with binary pixels and color values. Images are also represented using binary code, but instead of letters and symbols, we use pixels and color values. Think of a digital image as a grid of tiny squares called pixels. Each pixel is assigned a specific color, and each color is represented by a unique binary code. The number of bits used to represent the color of each pixel determines the number of colors that can be displayed. This is called color depth. Section 6. Putting it all together, from binary to images. Imagine you have a black and white image. Each pixel can be either black or white. In binary code, we could represent black as 0 and white as 1. So a simple black and white image could be represented by a grid of zeros and ones, where each digit represents a pixel. For color images, we use more bits to represent a wider range of colors. For example, a 24-bit color image can display millions of different colors. Section 7. The power of binary in the digital age. Binary code is the fundamental language that enables computers to process and store information. From the text we read on our screens to the images and videos we watch, everything is ultimately represented as a series of ones and zeros. Understanding binary code is key to understanding how computers work and how they shape our digital world. As technology continues to advance, the importance of binary code will only continue to grow.